This conference will now be recorded.
So in yesterday's class, we had a discussion on an important topic under NLP called topic modeling, and where do we use it? And we had studied a model called the LDA to do topic modeling technique. So as just a brief about yesterday's class, topic modeling will allow us to provide to organize a set of text under a summarized set of topics. So we can create a summarization version of different documents using topic modeling. So topic modeling plays important role in document summarization. Either it is a single document summarization or multiple document summarization. Here, when I say document summarization, it could be like a movie review or a product review or some legislative documents which you wanted to convert them as a summary or an abstract out of 10 documents. You might go create any model under topic modeling, and then those model would allow us to help in creating summary using natural language processing. So as such, topic modeling will allow us to discover hidden topical patterns, and we can also annotate them into different important words called the topics. And these annotations will allow us to organize them in a way so that you can compare them with the human summary also in a better way. So that's what we had a discussion. And when we discussed about topic modeling, where all we can use also, we had a discussion. Some of the most popular techniques are displayed here: latent semantic analysis, probability based latent semantic analysis, then the method which we had seen is LDA, latent result analysis. Then ID to vector is nothing but word to vector model. After constructing a corpus, we can apply deep learning method called word to vector model, and then we can work on topic model construction. So if you look at this, and we had a discussion about how to construct topics using LDA, and maybe to brief about how a topic modeling look like, it is displayed in the slide. Let's say if it is in the first document, it talks about gene, DNA, genetic, and second one talks about life, evolve, organize. Third one talks about completely about brain or neuron or neural network, and fourth one talks about the data processing. So data, number, computer, all those are given. So similarly, if it is in a news article, we can do topic modeling like this. The numbers what is mentioned at the right hand side are all the probability values or the frequency, how many number of times it is appearing, and how long this topic is aligned with the, sorry, these are all the words which is aligned with the generic topic what is mentioned. So we had discussion about this, I think. So today also I can share a bit of data set to do the same thing, and then you can also change and check how many number of topics are we going to achieve, because as LDA concerned, we need to fix the number of topics we wanted to have in our document. So how do we achieve or how do we measure that K is what a big question when we work in LDA. So I think we had a discussion about this also. So when we just refresh the LDA procedure, we go through each and every document, randomly assign each word in the document to one of the K topics. So LDA works by taking out each words what is come out of the pre-processing from each document, and then it tries to find out whether it is matching with the topic what is chosen or not. So this random assignment K of all documents, and then it is going to improve upon based on the probability, conditional probability value. So it is going to keep repeating the steps several number of times and reach a steady state wherein the topic assignments are going to be pretty good, wherein we are not finding any more topics are changing, or those assignments are okay with some threshold value, so that it will stop iterating, and LDA provides a fair good amount of topics for the given set of documents. So here, if we look at, we are very much concerned about this K. How are we going to choose K, or whether the K, whatever I have chosen, is enough to precisely summarize the set of documents what I have given as a input? That's the biggest question. So after applying the LDA model, I think I had shared a code with you in that the explanation for individual arguments are given here. So as we all aware, corpus is just a term, document term matrix, and we are going to use that as a model for LDA. And LDA, which you can construct from Gensim as a package, which is available in Python. So LDA model could be constructed using creating an object from Gensim packages. And here, if you look at corpus, you are aware what it is. What is number of topics? What this parameter indicate? This number of topics it's not an optional one. It is a required parameter. It requires the user to determine how many topics should be generated. See, here is a question like, how do we decide this three or two? Since we had an example yesterday of 5 documents with set of only few words as a corpus, we had decided to give number of topics as 3. But if we wanted to find out which topics are most relevant, or how many number of topics can I give for my document summarization, you can go think about, like, you have to count the frequency table of the given set of words. So you know how to create a frequency matrix. Like, you just need to find out document term matrix, and according to the number of frequencies it will be arranged. So the least frequency words you can just filter it out, and then the most frequent words you can just project it as a plot, and then check which words are all most frequently occurring words in the document, and then decide. Maybe you can depends on that plot, you can decide how many number of topics can I have it in my document summarization. So that's one way. So like least frequency topics can be filtered out, so that you can keep most frequency topics as the number of topics here. And then this ID2 word is also a second required parameter, wherein this LDA model requires our previous dictionary what we have constructed out of the given document. That's called a corpus. So from there, it takes up those words and then map into different string is what ID2 word does. So it is taking up that ID2 word from the dictionary what we have found. And this passes nothing but number of times the model need to go through the corpus again and again, like an iterative process. You are giving this as a number of process. So maybe if you are going with the number of lot of passes can be slow on very large corpus, because the corpus become big, so then the number of passes need to go on every pass become more, so it takes longer time to execute. So the greater number of passes, so that you can get more accurate model or more accurate results. But we need to see that what is our corpus level also. So these are all some of the considerations when we try applying the LDM model. And so this also we had a discussion further, like if you would like to go through one more example today, I might be sending a data set. You can apply the same code on the given data set, and then try finding out the frequency of every words, and you filter out the lowest frequency words out of it. According to the highest frequency words, you can decide the number of topics that you wanted to have, and you can see the difference in the result. So like here, let's say number of words in the document, we are going to have 6 words. And for example, the document might contain 1/2 the topic health, and 1/2 the topic of vegetables. So half of it health, and half of the words are considered to be vegetables. So here the output depends on the conditional probability. We need to go ahead with the example. So I'll show you that example again. Then how to improve the results here, if we look at it, the first one, what I have said you, is frequency filter. Frequency filter is the method what we need to customize for our own topic modeling technique, wherein we need to arrange every term according to its frequency, as I said. So how to achieve this term matrix? All of us know that how to form a document term matrix. Like, it is going to count the number of terms and how many number of times it is appearing in the same document. According to that, it gives 1 to number of times it is appearing. And you can eliminate lowest frequency, as we call it, as weak features. The most frequency words you can take it up. So before that also, like, if your corpus is so big and you don't know which frequency is more, you can arrange them in ascending order, and then move top three frequency words, you can pick it up. You can give k as 3 or 5, depends on the corpus strength. You can give frequency level also. And then the second one is parts of speech tagging. So I think we had a discussion on parts of speech tagging in the 2 3 classes before, I guess. If you want, I'll share the code once again. Parts of speech is nothing but like dividing the sentences into subject, verb, noun, determiner, adjective, noun phrase, verb phrase. So those kind of things, we will be dividing them in the given sentence. It looks like a parse tree, how we might have studied in compiler design, in that. So POS tag filter, it is going to look out the context than the words what we have it in frequency filter. So POS tag filter is more looking at the context of the features. So topic modeling tries to map out the recurring patterns of these terms into topics. This POS tag, let's say an example here, in contain terms such as within, upon, except, and these are all some of the POS tags. MD as a POS tag. I'll show you the table also what these tags are indicating. Just a second. Yeah. If you look at this slide, some of the parts of speeches are POS tags. What is defined is already given in the previous class slide itself. So when we do pre-processing itself, we can assign POS tags for the given sentences. So POS is nothing but parts of speech tagging. So it's going to assign individual labels for the different tokens what we found. So if you look at CD is nothing but cardinal number, DT is determiner, and so similarly it goes on by defining the individual labels for the different words or the tokens what we say it in pre-processing. So example, how does it look like? Also, we had seen. I'll also give or run the code again. So if we look at this here, if we look at example CD, so it is already defined what CD is. You can refer always this table. CD is cardinal number, and if you look at MD, MD is a model, and if we look at IN, it's a preposition or subordinating conjunction. So these are all the resultant values of the POS tagging process. It is also a pre-processing technique which could be applied before applying LDA model. And then you can use these parts of speech tag filters also, where when you do not want to have these like a cardinal determiner or prepositions, or I don't want to consider like models may or must and all, you can eliminate those set of words out of the corpus. So this is also one of the method of improving LDA model before applying them or before choosing K what it is. And the last process what I have yesterday itself I've told you about is batch-wise LDA. So batch-wise LDA concern, like if you would like to retrieve or have more important topic or the terms, what you can do is you can divide the each individual corpus into different set of batches. Maybe when we do sampling 10 rows at a time or 100 rows at a time, we can pass it. Similar way here also, you can fix how many number of topics am I going to apply as a batch. So then you can run the LDA multiple times on the different batches. So when you are doing a batch-wise process, like the topics what we get out of the batch-wise LDA could be an intersection. Intersection, what is appearing in batch one need to be appeared in batch two also. So that way, intersection of all LDAs you could collectively have as a set of topics for doing LDA. So just to wrap up how to improve LDA, I'll repeat the three process again. First one, what we can do is a frequency filter applying thing you can do before LDA. What is frequency filter? Like you can use pre-processing method to identify individual document term metrics along with its frequency values. After finding out the frequency values, what we can do is we can arrange them in ascending order, or we can plot them, any graph you can use and then plot them, distribution plot, anything you can use and plot it. Check whether how many number of high frequency items or words are you getting, or lowest frequency. Maybe if you are getting some three set of words with the highest frequency as 10, you can fix 5 as the number of topics, and you can eliminate the least frequency words, whoever has got 0 or 1 in the frequency table. So that's one of the method to improve the LDA. And the second one is about parts of speech tag filter. Here it is going to look out the semantic level of individual words. When we say semantic level, what we are trying to do is, after doing the pre-processing things, like after dividing the given sentences into set of tokens, each token would be, you can apply a POS tagging on the given sentence. So then those will be assigned with the POS tags like NN, NP, IN, CD, all these. You can eliminate these things which you do not contextually feel it's so very important in the document summarization. You can eliminate them from the document or in the corpus, then apply the corpus for the LDA model further. The third process is batch-wise LDA. Like you can retrieve most important topics, and then you can apply use any of these method. And then further, if you feel like your corpus is too very big, obviously, like if you're handling 100 reviews at a time, it could be bigger in size, wherein you need to process them either batch-wise LDA. Here, you can divide them like a sampling technique. You can divide them into 10 or 15 or 100 in a set of batch, and each batch you need to apply LDA multiple times, and then those words are going to be like intersection of all the batches. So this thing I haven't run any code for as such in my model. So, and I found one more interesting thing also, like how to measure the performance of LDA model. For that, I found two measures. One is perplexity and topic coherence. These two are a convenient measure to judge how good a given topic model is. Maybe we can try out this topic coherence and the perplexity statistical measures to identify how good the model is. So in particular, like topic coherence score would be more relevant to find out. And If the measure is lower, then the model is good. That's what I referred and checked also. We can use the computing perplexity on the corpus, what we found out of the LDA model. And then this LDA model, whatever text you have used, ID to Word and coherence, you can save it with CV and you can print that and check what is the coherence of the given model. So these two measures we can use in LDA and then we can check it also. And one more I would like to share is like word embedding approaches, which is not given in the title, but I think term frequency and inverse document frequency we had already discussed. So what is embedding approach? So as we all aware that before pre-processing itself, how these words are represented in computers so that it could perform some analysis out of it. So we found an interesting topic called Word2Vector model. So here word embedding refers a numerical representation of the given words. So there are several word embedding approaches are there. It has its own pros and cons in it. Some of the interesting word embedding procedures are bag of word model, TF-IDF scheme, or Word2Vector model. Bag of words is nothing but where you will be collecting a set of tokens as the final tokens of the given documents that become the bag of words model. So it is one of the simplest word embedding approaches. Here is an example. Similar examples we had already discussed, but not the same. We have a corpus with three sentences like I love rain and rain go away and I'm away like that. There are three sentences. So when you convert them into word embeddings, if you would like to use bag of words approaches, like the same term frequency model, we create a dictionary of unique words from the available corpus. So in the above corpus, we have the following unique words like I love rain, go away, I am are the words I am choosing as a unique words out of it. And what we can do is for the given or for the final set of unique words, we are going to represent them with a frequency matrix. So here, if we look at it, the document term matrix, how it is going to be formed for the first sentence, I love rain is. See, I love rain is present in the first sentence. So I love and rain are going to be marked as 1. Go away am is not there in S1, so it is all marked as 0. Similarly for S2 and for S3. So the bag of word representation looks like this, wherein the words are converted into numbers. This is one of the simplest word embedding where we convert a word into a vector. So this is just when we go with this, if you look at the bag of words model in the S2, where here rain is appeared twice, so it is given as 2. So this is how the frequency would be counted. If you look at this document, maybe if you look at this document, the topic what is appearing most is what rain. So that way topics are assigned with the highest frequency. In the previous slide what I had explained, same thing here. In TF-IDF, as we had a discussion earlier, I'll just run through this also fast. It is also similar like bag of word approach, where instead of adding zeros and ones in the embedding vector, you can also add floating point numbers that contain more useful information compared to zeros and ones. So here, having high frequency of occurrence in one document, maybe the same word have a less frequency of occurrence in all other documents. So term frequency, to identify that, we have a formula wherein number of occurrences of a word divided by total number of words in the document. This is the formula for identifying term frequency. For instance, if we look at the sentence S1 from previous section, I love rain, every word in the sentence occurring only once, and therefore the frequency of all the words, it is marked as 111. On the contradictory version, like in sentence 2, this sentence is appearing twice, but for the others it is going to be 1. So the inverse document frequency refers the log of the total number of documents divided by the number of documents in which the word exists. And this is the formula. This also we had a discussion long back. So the IDF value for the range is going to be when we calculate this IDF, it is 0.1760. So when we look at TF IDF, it goes with the floating point values. But in bag of words model, we will be using either 0 or 1, whether the word is appearing or it is not appearing. That way we will move on with values. But what is last one, the word in the word embedding, word to vector model is? What is word to vector model is? So here, however, in the natural processing system, we treat words as the some values. So example here just given, you can have, you can also represent the atomic unit, cat, dog, everything with some numbers. Word to vector is also like taking up each word and then represent them into a vector model to overcome some of the obstacles what we look at in the system level natural language processing. So here for word to vector, we have continuous bag of words model and skipgram. This continuous bag of word model which allow us to predict target words from the source context word. It is like in the filling blanks, if one word is missing, are we able to predict the next word is what? Continuous bag of words model does. So which allow us to predict target word from the source context. So the model itself is going to look out the source context and then allowing the model to predict the next word what is missed out. Skipgram predicts source context words from the target words. From the target, it is going to identify what all the words will be apt to the skipped word or skipped gap is what skipgram does. So Gensim also, I'll tell you this. There is an example here. Example between and the difference between CD overview and skipgram is given here. The cat ate dash fill in the blank. In this case, maybe it's food we can give. So the output indicates the cosine similarity between word vectors and no, not this. We will be looking only this. So skipgram, if you look at, there are three dash and food if you give. Complete the word context. In this case, it is the cat ate food. So if we look at here skipgram, it does not allowing to identify whether a single or maybe a bigram or a trigram, it could be any gram. So we need to complete the word context depends on the depends on the context. These grams are going to be filled, but this it is going to fill the depends on the set of words what is available in the corpus, and then it start filling the gap here. So it goes working on CVO bag of words model or skipgram. When we look out a skipgram, it is more tougher than bag of words model because skipgram, if we say that, we are not very sure whether either only 1 gram is skipped or 2 gram or multiple grams skipped, because the gram indicates that either could be a single word or multiple word or more than 2-3 words also could be. So that's a tougher thing when we go with skipgrams. And some of the applications under word embeddings are you can work on sentiment analysis. You can also think about speech recognition softwares, information retrieval, and even question answering chatbot also we can also create using word embeddings, because it is going to, like, even in Gmail, the Grammarly things whatever gives is also based on word embeddings. So that's all about today. Named entity recognition we'll see tomorrow or in the next class. If you have any questions regarding LDA model, we can discuss. Maybe next week I could also try out this Word2Vector model using deep learning, and the code also I'll try executing and get back to you with the code. because it uses neural network perceptron, multi-layer perceptron, and then we have to go for backtracking also. I mean, backpropagation neural network also we have to try. So I'll try those two and come back to you with a word-to-vector model. Till then, if you people have any doubt, you can ask me now, or I shall send you the data set for LDA model again. You can also try out this alone. We can try out the first one, like frequency filter. We can eliminate, and then we can go ahead. Okay, so Shashi is saying next class with one case study. Which one you want me to explain? How to improve LDA, or we could go with word embeddings? Okay, sure. Word embedding, we will go with a simple example in the next class. Okay, both also we will try. Maybe we will try with the frequency filter and parts of speech tag filter. By applying these two, how our LDA model is improved, we will see first, and then word to vector model we will try. See, in the past example, if we check it out, just hold on, I'll just launch Spiral. Till then, if you have any doubts, you can type in. I can try out answers also. The pre-processing itself, the last one I had explained you how to apply a POS tagging. If you have already done with, maybe it could be easy for you to recognize what was POS tagging was. I had reset everything. See, there is a text. James Smith lives in United States. It's given. So we are applying a POS tag as the word tokenizer. So it's going to identify what these individual words are according to the parts of speech is what it's actually displays. Okay. If you look at the name noun phrase, Smith also kind of noun phrase. Each one, like these are all the POS tagging. I think in also we had a discussion kind of preposition. So in is a preposition, and the is the determiner, and this is also noun phrase, and state is also noun phrase. So all these explanations are given in the parts of speech tagging table. We can always refer this and what that individual tags are represents. So in this set of example, like when you filter parts of speech tagging, you can always eliminate these like models, determiners we can eliminate, and prepositions we can always eliminate, and this two also we can eliminate. Maybe these are all important because third person singular present, if you look at VBZ, there is an example. See, lives or lives is given here. So we are saying James Smith lives. We are not saying directly. It is a third person singular representation. So this we cannot eliminate. That's the only verb what we have in the given sentence. Because when we look at this sentence as a human perception, we have only one verb representation. Right? So if we eliminate this, there is no meaning between James Smith and the United States. So we are saying that they are living, or he is living in the country. So we cannot eliminate that. So POS tagging is also an approach where we can consider most important parts of speech as a topic. So this is one of the way applying filter. And one more thing is like how identifying stop word and converting them into um, individual tokens we have already seen. After that, you can arrange them in assigned order and then have a distribution plot to show which are all the topics important. So maybe I'll try out the code on my own and then get back to you how to apply them. So I assume that there are no questions or queries. Maybe we can wind up the class for today. I'll get back to you Word2Vector model and the how to improve LDA in the next class. Thank you so much for joining today's class. Thanks everyone.